Alright, so this is going to start with a review of what we talked about last class by solving quadratic equations by factoring. So the first equation here is not in the correct format. We need to write this as a standard quadratic with a 0 on the other end. So to do that, we're going to add 8 to both sides. We're going to add 8 to both sides. We're going to add 8 to both sides, that way it gets rid of that negative 8. So we're left with x squared plus 6x plus 8 equals 0. And now, just as a reminder, this has 3 terms, so we're going to factor the left side now using a cross puzzle. On the top we have 8, on the bottom we have 6. And we need to find two numbers that multiply to give me 8 and add to give me 6. Alright, pause the video and try to figure those out. Alright, we should get 4 and 2. Now, because the leading coefficient here is 1, I don't actually have to split the middle term here. You can split the middle term, you'll get the same answer, but you don't have to. Instead, you can just write your two factors with an x out front and then the two side numbers afterwards. And again, that only works if your leading coefficient here is 1, if the number in front of the x squared is an invisible 1. Now, in order to actually solve this, we have to split this into two cases, because if this whole thing equals 0, one of these parts has to be equal to 0. So either this is 0, this is case 1, x plus 4, or this second part is 0, case 2. This is case 1, this is case 2. Alright, so either x plus 4 equals 0, in which case, well, if something plus 4 is equal to 0, that's just negative 4. And if something plus 2 equals 0, that's just negative 2. Okay, so we're going to do the same for this one over here. Now you'll notice it's already in the correct format. However, let's set up the cross puzzle, and you'll find there's a little bit of an issue. So on the top we're going to have negative 2 because it's 1 times negative 2, it's a times c on top. And on the bottom we're going to have 16, which is b. Again, a times c goes on the top, so 1 times negative 2, that's negative 2. And on the bottom we have 16. Now the question is, are there two numbers that multiply together to give me negative 2 that add together to give me 16? And the answer to this is a flat out no. No, there are not. So this is straight up unsolvable. Unsolvable. And therefore, this equation, this quadratic, does not factor. So the issue with the second equation is that x squared plus 16x minus 2 does not factor. So if you're given a quadratic equation, the first thing that you want to try is factoring, because it's the fastest method. If that doesn't work, there is a universal method to solve any quadratic. And it's called the quadratic formula. Now, the quadratic formula is something that is taught in Algebra 1 usually, but sometimes it's one of those that you get to in an honors class and you don't get to it in a standard class. Alright, so the quadratic formula is if ax squared plus bx plus c equals 0. Again, it's the same form of a quadratic equation as we've been working with. If it's in this form, then x is equal to big fraction bar. And again, a, b, and c represent the coefficients in front of x squared, x, and the constant respectively. Alright, so the quadratic formula is the opposite of b plus or minus the square root of b squared minus 4 times a times c divided by 2 times a. Now this plus or minus here just means that the first solution to the quadratic equation is where this is a plus, and the second solution is where this is a minus. So again, quadratic equations have two solutions because quadratic functions have two roots. So when this is a plus, you get your first solution. When this is a minus, you get your second solution. So let's put this into action with the equation that I was working with before. This is x squared plus 16x minus 2 equals 0. So in this particular case, I'm going to start using pen here. X squared, oh, much better, plus 16x minus 2 is equal to 0. All right, in this case, remember, a, b, and c are the coefficients. A, b, and c are the coefficients. So we've got a equal to 1, because that's the number in front of x squared. It's our leading coefficient. B is equal to 16, and c is equal to negative 2. So now we're going to plug everything into the quadratic formula. So we've got x is equal to the opposite of b, which is 16, plus or minus square root of b squared, b is 16, minus 4 times a times c. So a is 1, c is negative 2. This is all divided by 2 times the leading coefficient a, which is 1. So any equation with a degree of 2, any quadratic equation, can be solved with the quadratic formula. Now we have to simplify this, but that is easier said than done. That's okay. So let's start by simplifying this piece by piece. I usually start by simplifying this radicand completely, and the radicand is the part that's under the radical. I simplify the radicand completely, and I simplify the denominator in this part, and then I deal with the denominator. So we've got negative 16 plus or minus, and now let's simplify this radicand, and if we need to, we'll simplify the radical itself. So 16 squared, and feel free to pause the video for each part of this. 16 squared is 256, and then negative 4, because there's a minus here, times 1 times negative 2. Well, negative 4 times 1 is negative 4. Negative 4 times 1 is negative 4. Times negative 2 is positive 8. This is all going to be over 2 times 1, which is 2. So I simplified this, I simplified this, I simplified this, and I simplified this to go from here to here. Now, 256 plus 8 is going to be the square root of 264, still all over 2. And now 264, we have to check to see if this radical can be broken down. Now 264 is not a perfect square, so we do actually have to break it down with a factor tree, and I'm gonna do that right in the middle here. Okay, now there are several ways to break this down. Any one of them will work. The way that I saw right away was 2 and 132. But you can do stuff like 4 and 66. You'll still get the same primes when you break it down all the way. Now 2 is a prime number, so that's the end. That is a branch. That's a final branch in our tree. So I'm going to underline it. Now 132 breaks down into 11 and 12. 11 is a prime number, so that's another final branch. 12 breaks down into 3 and 4. 3 is another prime number. And 4 breaks down into 2 and 2. Those are both prime numbers. So our primes are 2, 11, 3, 2, and 2. So now we have to find pairs. So our pairs are, we just have a single pair of 2's. Now because there's just one pair of 2's, the only thing that should go outside of the radical is a single 2. Because 2 times 2 is 4, and the square root of 4 is 2. So there's a pair of 2's, we bring a 2 to the outside. There are no other pairs, so we don't multiply that 2 by anything. If there was, say, another 3, then we would have a pair of 3's, and we would have 2 times 3 outside of the radical. But we don't. So now we have the remainder, which is everything left. And so our radical is going to have 11 times 3 times 2 underneath it, because those are the things that didn't pair up with anything. 11, 3, and 2, 11, 3, and 2. And now we simplify this, which is 2, and then 11 times 3 times 2 is 66. So my simplest radical form is 2 square roots of 66. Okay, so now we can replace this square root of 264 with our simplest radical form, which is 2 square roots of 66. Over 2. So let's, I'm actually going to rewrite that up here. I did leave myself some space. So now we have to divide everything on the top by 2. Now normally this would give you a fraction, but both of these are actually divisible by 2, so it works out. Negative 16 divided by 2 is negative 8. And we still have the plus minus here. 2 square roots of 66, and we take a 2 out of it. We've just got a single square root of 66. And now we have this plus or minus. We can't simplify the square root of 66. We can't combine it with negative 8 or anything like that. So we're going to have to leave our answer as x equals negative 8 plus the square root of 66 as our first solution, and x equals negative 8 minus the square root of 66 as our second solution. And so the reason why this quadratic equation couldn't be solved with factoring is because our two solutions are not nice at all. They're very, very mean. So when you have two solutions that are not nice at all, the quadratic will not factor. If the solutions are nice, it will factor. That's the general rule. And yes, sometimes you will get solutions like this. Sometimes you will get solutions that are imaginary. As a matter of fact, there is one of the sample problems, just one, but one of the sample problems on the back has the square root of a negative number, which means you're going to have to reintroduce I into the problem. Or you're going to have to introduce I into the problem. And just as a little review, you don't have to write this on your notes, but I will suggest that you flip to the back and just to remind yourself that I is equal to the square root of negative 1. Alright. Bye. And yes, please complete the sample problems. Your homework is in Canvas.